Okay, so we look at our divisor, the 0 of the divisor, or what will make this divisor 0. You're going to hear me say 0 a lot today. What makes this 0 is a 1. You write down your coefficients and making sure nothing's being skipped. Yesterday we talked about how, wait a second, if I start out with an x cubed, I better see the next descending power, and the next descending power, and then no power, or just a constant term. And if one of those are missing, I better have a 0 in its place. Okay, so I bring down my first term, multiply, 1 times the box number 1, add. Multiply, add. Multiply, add. I was checking to see if you at least got your remainder to be 1, I knew you did your stuff right. And then if I walked around and I noticed, wait a second, you didn't get the same remainder as I did, that's whenever I needed to have conversations. Some people weren't done yet, so I just wanted to make sure, wait, do you have the setup right? If you chose long division, no worries. It's just I'm going to constantly use synthetic division. That's what they use in college algebra. That's what I'm going to be using. Because of this wording, it says use synthetic division to divide. I want to see it as a quotient. So x squared minus 1x plus 2 plus 1 over x minus 1. There's this rational root theorem. When we have a polynomial, our possible rational zeros can be found by taking factors of the constant term divided by the factors of the leading coefficient. So if I'm given a polynomial, I can look at the factors of the constant. So factors of a sub 0, or factors of the constant, divided by factors of the leading coefficient. And these are going to give my possible numbers that can be x-intercepts. We'll see examples of what we mean here. We're going to find the zeros of this polynomial using synthetic division. And that tool of taking the factors of our constant term divided by factors of our leading coefficient. I'm going to take factors of the constant, negative 12, and I'm going to divide them by factors of the leading coefficient, 1. So my numbers that I'm going to try in synthetic division, let's see, factors of negative 12. We've got 1 and 12, 6 and 2. Maybe I should put these in order. 1 and 12, 2 and 6, and then we've got 3 and 4. And then the only factor I'm going to be dividing by is 1. Well, wait a second. And we talked about how positive and negative numbers, like if I had a positive 1 with a negative 12, negative 1 with a positive 12, we talked about how I need to realize plus or minus any of these can be a possibility. So really, what am I trying to find? Because every single one of these divided by 1 is just the top. These are my possible numbers I'm going to pick from. We're going to start testing these, and we're going to start with positive 1 and see if it works. If positive 1 works with synthetic division using these coefficients, and what I mean by works is the goal is to have no remainder. If there's no remainder, then that means we found a 0 or an x-intercept. Test to see if 1 gets us no remainder in this. That's the goal. I almost want to put 0 here. This is the goal. If I don't reach a 0 in that last column, I erase and start over. And then we start the multiply add deal. Multiply, add. Multiply 3 by the box. Put it in the next column. Add. Multiply the negative 8 times the box. Whoa. I don't get it, so I physically erase, realize that positive 1 is not the answer, and start over. So positive 1 does not work. I almost want to like cross out positive 1. But I need to realize negative 1 could be an option. So let's go through and try negative 1. I still bring down my first term, and then I'm going to multiply and add. Multiply, add. Multiply. Whoop, whoop! So we get negative 1 to have 0 as a remainder. This means negative 1 is one of the zeros. Great. Negative 1 is an x-intercept. But now I need to find more. So let's think about what happens. Let's determine what this quotient was. Kind of like warm-up. I started out with x cubed. It's going to decrease by a degree. So now my remaining factor is 1x squared plus x minus 12. The key word here, or key word today, is zeros. We're going to try to figure out what would make this leftover factor a 0. Maybe I could do some type of, I don't know, factoring, whether it's bottoms up or quadratic formula. I can do something with this to figure out, well, what are my other zeros? So multiply add method, we're looking at x minus 3, x plus 4. What will make each one of those 0? Positive 3, negative 4. So these are our other two x-intercepts. I have 3 of them. I have negative 1. I would have an x-intercept at negative 1. You don't have to graph it, I just want to show it. X-intercept at negative 1, x-intercept at positive 3, x-intercept at negative 4. And then on Tuesday, we're going to realize, oh, hey, wait a second, it's an odd degree. Here's my end behavior, and so on. Oh, hey, wait a second. I'm going to travel back to that previous slide. Just because, wait a second, this pool, right? We had this pool of numbers we picked from. And negative 1 worked. Notice how 3 and negative 4 are also in our pool. Positive 3. And granted, there's not a plus or minus here by the 4, but we recognize positive and negative numbers can be here. Just wanted to make note that this pool is useful. Okay. And I start making a list. 1 and 8, 2 and 4. And I'm going to check to see, okay, if they were divided by the only factor for 1. So really I'm looking at plus or minus 1, 2, 4, 8. So I just start picking positive 1 and then going through the synthetic division steps, bring down your first term and then multiply, add, multiply, add. Hey, nice pick. We got a 0 as a remainder, so that means it's a 0. It's an x-intercept. So 1 worked. So the remaining stuff, let's see, I started out with x cubed, and now I'm left with x squared minus 2x minus 8, because it decreases by a degree. And we got to ask ourselves, is there any way to figure out, well, what are the other factors? I could either use multiply, add, quadratic formula, bottoms up. Figure out, okay, negative 4 and 2, multiply to negative 8 by adding negative 2, and then figure out what makes each of these 0. What are the zeros? 4 and negative 2. Notice how those are also in my pool. Positive 4 was in my pool of numbers. Negative 2 was in my pool of numbers. So do we always have to start with positive and negative 1? No, it's just those are the nicer numbers. So our pool of numbers, I've got to realize, okay, 1 and 5 divided by 1 is just positive or negative 1 and 5. But what if you took 1 divided by 2? So let's start with, I don't know, positive 1 and see if that works. Man, I guessed really well. We get a 0 in the or a 0 as the remainder. So positive 1 is a 0. Let's use the bottoms up method. So what multiplies to negative 10 adds and gives you negative 3. And then since it was x squared, I can divide them evenly into x and x. Divided by leading coefficient 2. If it reduces, that's or if it's an integer. If it's not, I bring the bottom up. Like in the first case, does not reduce to an integer. And I figure out what will make each of these 0. And negative 1 is one of my zeros. Notice, yeah, we dealt with the 5 halves. Wait, we got 5 halves. And notice how it is still in our pool of numbers. Same with negative 1. Negative 1 is still in our pool of numbers. These problems are different than what is on your schedule. Not only that, but the directions I have up here are different than the directions in your textbook. I want you to look at page 362, look at these problems, and I want you to find the rational zeros, just like what we did in class. So you develop a pool of numbers using the factors of your constant divided by the factors of your leading coefficient. You pick, and this is the hint, you pick either positive 1 or negative 1 to work with first. And then you've got to figure out, okay, can I factor it? Can I factor the rest? And by the way, they are all factorable. Just like in notes. I'm not giving you something with i's. I'm not giving you something with any square roots. All of these problems will end up being with integers, and one of them will either be positive or negative 1.